Hello, friends. So this morning I want to talk to you about really something that is an issue every time that I think you do any type of communications. And I was actually sitting here this morning planning a video out on doing this, but one of our channel members, Jeff, he asked a question about this and he's going to run into it Monday. And I was like, well, let me go ahead and just hit a live on this and let's talk it out. Because so I put a video out, I'm not a video, I put this image out yesterday. And this was a programming quiz, and I said in it that I was putting 102.9 on a flow, and I'm reading it across the network, and I'm getting these four numbers right here. And so, first of all, I do have to give some credit to some people who did get this or got close enough so that I'm going to give them credit for it. First of all, Hayden Paul, he absolutely nailed this and nailed it pretty quick. Stephen Carter also got the answer to this. He was a little slower, but he has been he's had some surgery lately, so I'm going to assume he has a doctor's note. Now, this guy, next guy, may be the most shouted out person on these quizzes, but Tony Leroy, I got to give you credit. Tony Leroy got right to the finish line and just couldn't quite come up with something strange was happening. And then Ian Cockrell also, he got really close. He saw the hint. There was a hint. Don't worry, we'll talk about the hint and everything later. But he saw it, but couldn't quite figure out how to work with the hint and figure out the answer. But okay, first let's back up and let's talk about what Jeff has going on, because I think Jeff's is kind of leads us into the basics of it, and then we'll get into the one that I posted this week is one I had to do this week. So as I say, this is a common thing. But so Jeff is working on some scales and he's reading the data through explicit messaging or no, Modbus. Can't remember. And that's what's tricky about this. It doesn't matter which one you're reading it over. It's always an issue. Um, but he's reading some scale data and he has five scales, I think it was, and four of them are working perfectly. The other one is kind of garbled up. And so the ones that are working perfectly, they're 15,000 pound scales. That's their max number. The one that is not working well is an 80,000 pound scale. And so he's messed around and he's like, man, the maximum number I can get out of this thing is 32,767. And so we need to talk about why that number might be special to this. Also, yeah, we got to get a Captain Obvious credit. I even warned everybody in this post. I'm like, don't do anything dumb or try to tear this one apart. You know, I didn't respond to anybody. I hate it. We had to take on one of the quizzes down the other week or earlier this week because of this. But yeah, one Captain Obvious person said, well, why would you take this number and split it into these four cells? Well, maybe I didn't. Maybe that's how data works. So let's talk about 32,767 and Jeff's 80,000 pound scale. And to do that, we are going to go and open up our calculator. Whoops, that's a zoom. We're going to hit this one. We're just going to go to the start menu and start typing calculator. How to bring up our calculator. And let me get it over here on the right screen. And this is the standard view of the calculator. Let me minimize this. That way you're not looking at all that distraction. But you have these three dashes right here. And if you open that up, we can go to our programmer calculator. And so I'm going to enter that number that Jeff found of 32,767. And notice that that puts ones in everything but the 15-bit. Now, I'm not going to talk about the 15-bit in this live stream because we have other videos on it, and I think it'll just throw us off. Actually, let me stop that. Don't put in the comments that it's the sign bit. It is not technically the sign bit. Don't do that because that causes even more confusion. Mainly, that's our maximum positive number. So if we have an 80,000 pound scale, what happens to the rest of the value? And so let's go back to our calculator and let's enter 80,000 pounds. So now we have 80,000 pounds. And notice these are grouped into fours. So this is 0 through 3. The next one is 4 through 7, 8 through 11, and 12 through 15. This is your 16-bit integer. So if we're talking over Modbus or something, it usually is an INT or 16-bit integer. If you're entering N7 into a micrologic, same thing, it's going to be 16-bit. So then, notice with that 80,000 though, we are using the 16th bit, which is going to be somewhere else. And Jeff, that is why I said check the cell before or check the cell after. Now, I did tell you one thing wrong because I was driving, I was tied up when I did it, but let's figure out what that bit is. And yeah, I know for a lot of you it is obvious, but this is a 1 in binary in some number. So I'm going to highlight down here and just enter a 1. And that means we're looking for a decimal value of 1. So my wild guess is that you have a decimal value of 1 in either, now here's where it gets tricky. Hopefully the cell right after, but it may not be the cell after. And that's going to spill us into this next piece. So now let's go into Studio 5000. Now, Jeff, and a lot of you, you're working with Connected Components Workbench. I'm going to put a video at the end of this that will tie all this together. You're not going to have a few of the instructions that I'm going to talk about, but really we need to understand the concepts. Don't worry about getting exactly following the instructions. So if we go over to Studio 5000, then right here is the data. So I'm going to just right click and I'm going to monitor it. And we got 37, 63, 31, and we'll make a negative 123. Those are the exact same values I had over here. So I know that this flow meter was throwing a 32-bit floating point number in. And this should be it. Now, if we open up each one of these arrows, see, these are cents. If I open this arrow up, well, there's your 8 bits of one of them. Then we got 4 of them. 8 times 4 is 32. So there is our value. Oops, you're not seeing anything I'm doing. Thank you, Jeff Kuiper. Good morning. Apparently, I need more coffee. I didn't know that switch screen, so we'll do all that again. So, so I was over here. I right-clicked this because here's that data. Negative 37, 63, 31, and negative 123. Don't worry what I've got here. We're going to land back at this by the end of this. I right-click it and I monitor it. There's those numbers, and that matches these numbers that I gave you over here. So our first dilemma is we need to get all these numbers combined into one. Now, I'm going to show you the way that I usually see it, but you know, the further along I get, the more I kind of like the second way because it is more versatile. Also, kind of going back to liking the second way better, Hayden Paul, who was really the person who got it first, works for Siemens. This is not an Alan Bradley issue. This is not a Siemens issue. This is an issue anytime we do this type of communications. And so I'm going to show you the way that I see it done most. And then you're going to see that if you're using connected components, you're not going to be able to do this. Also, if you're using other software, you're not going to be able to do this. But I'm going to show you how really we can do it with any software. Okay, and I did remember this time to go back to my screen. But so first thing we got to do is we've got to combine these. And so what I'm going to do is I'm just going to bring a new rung down right in here. You can bring it into a new program. And then I am going to bring down a copy instruction. That's on the file miscellaneous category. Actually, you know, and this is a bad habit of mine. And it wouldn't matter for this, but I'm going to bring this down. I'm going to right click and I'm going to go to instruction help because I should not do this. And just old school, I do. Notice it says copy file, and then we have synchronous copy file. These are the same thing, except when you use the CPS instruction, nothing can write to the data. Whoops, I don't know why that's popping up. Nothing can write to the data while it's doing the copy instruction. So let's go back over to Studio and talk about why that could be important. Because yeah, really, you're doing communications if you're doing this. So I need to try to do it the right way here. This is an IO link module. And if we go up, it's actually, how many? 446. So we have an RPI on our on our data, on our IO modules over here. I'm not going to go in it and find it, but every so often, this is going to update this data. And it doesn't matter where it's at. So let's just go back down to that 198. I'm just thinking about Margie right now, who was in my last class. She probably sitting there. Oh, look at Tim, he's scrolling. I get on people to class all the time. Quit your scrolling. There's better ways. But okay, here's where we are. So if we were coming down through here and that RPI hit right between while it's doing this copy of 199 and 200, it'll stop doing the copy and it's going to update this data. And that means that the first two numbers are going to be your old data and your second two are going to be your new data. So, and honestly, I don't know there's ever a time that you shouldn't just use a CPS instruction. Now, a very bad habit of mine is I almost always use a copy because the CPS didn't used to exist. I don't know. Does anybody know of a reason you would ever not want to use a CPS instruction? I can't think of it, but all right. So now what we're going to do, we know we need to get this data right here. This 198 is the beginning of the data, and we want to get it into some singular destination. Now I'm just going to call this my copy combine. And I'm not going to create this yet because that's the important part to understand about this. Now I'm going to go ahead and right click the CPS instruction. We're going to go back to instruction help. And I want to go down to this length. The length is the thing we have to understand how this is happening. So the length says the number of destination elements to copy. The key word being destination. Now, what they don't 100% nail down here is this really is binarily how many ones and zeros do you want me to copy? So we know our data is in 198, 199, 200, 201, and we know each one of these is 8 bits. That means that we need a 32-bit number. Now, a 32-bit number is the default data type of the control logic. So if I right-click in New, Copy, Combine, notice it defaults to a dent. So I'm going to hit Create on that. And then I'm going to right-click Copy, Combine, and we're going to monitor it. And I'm going to hit the arrow by it. And we see in there, we have 32 bits. So we've made one number 32 bits long. And so I'm going to put a length of 1, and then we are going to finalize that. Okay, so now we have a destination of copy combine. In fact, I should make this where we could, yeah, this is a good exercise. Should I do this now? No, we're not going to. We're just going to go look at copy combine because we know there was, actually, let's go, yeah, we'll go look at copy combine. And mainly we see we have ones and zeros and definitely 0 through 7, which would be 198. And then 199, which is 8 through 15, definitely has stuff. And then 16 through 23 definitely has stuff. And then on to 31. Okay, so that gets us to here. Now here's where it starts to get tricky. Is now, originally this was a floating point number. We're actually going to add a second copy to this. So I'm going to bring, and I've really got to get a better a better habit. We need the CPS instruction. And I'm going to take that copy combine, and I'm going to make that copy combine real. And I'm going to also make it a length of 1. Now I want to be able to see this data right here just so you can see what's going on. So actually next one I'm going to do is I'm going to go to the Compare tab and I'm going to bring down an EQ instruction. Also, if you were before 36, this was an EQU instruction. And I'm just going to put, actually I want to put both of those so we can see both of them. So I have copy combine. I'm going to be that it's equal to 0. And then I'm going to take my copy combine real and that it's equal to 0. And then, oops, I forgot to create copy combine real. So we're going to right click new, and I want this to be a real number. Okay, now you notice we have a red X here. So here's something you can do, and I can drag any old instruction down. When I say, and it's funny, I'll tell people in class, just drag any instruction down, and they'll be like, well, which one is that? I'm like, anything. We drag anything down, we highlight the shape, and we type NOP. That's a no operation. That's going to give us green. It's not going to actually do anything. So we'll go ahead and finalize that. And we are going to get some incredibly insane number. This is -7 to the -36. Now, I don't really get into a lot of math on this channel, but pretty much this means we need to shift this decimal and negative, so the number gets smaller, this direction 36 times. So we have an incredibly small number here. And we know, whoops, if we can get to the right place, we know our initial number was 102. We're nowhere close to 102. Now, most of you got to around here, and it's funny, even in my class, you'll get to about here. And most of them are like, well, go ahead and just use that swap byte and start throwing stuff at it. And so in class, I'll be like, they'll be like, yeah, we need a swap byte instruction. I'm like, oh, what's a swap byte instruction do? It's like, it'll fix your number. I'm like, what do you mean fix your number? Has it got a flat tire? I mean, what is it fixing about the number? And so it's funny, most of us have heard of the swap byte. We know the swap byte, but we don't know what's going on. So I'm not going to give the full lesson that we do in class because we don't have enough time. But what I always say is most of your data coming across the network is in bytes. It is 8 bits. So even when we go back to our original number, right click here, we monitor it. These are single integers or 8 bits. This really is how the data goes. Now, I know this is not a perfect analogy, but I always say, some people can pick up a lot of paper. Some people can only pick up a little bit of paper. Now, rarely, notice we have A, we have B, we have C, and we have D. So this represents 198, 199, 200, and 201 of our data. Now, here's the trick to this is rarely somebody will pick up all 4 of them and set them so they're in the right order. Now, a lot of things divvy things out one at a time. So there is 198, 199, 200, 201. And when I pick them back up, my data is now reversed. Now, some systems, they can pick up a little more. No, I know it's paper. It's just an analogy I use. Some of them are going to do 16-bit. They're going to pick up 198 and 199. They're going to set them over here. Then 200 and 201, they're going to set them over here. And that's going to get us to CD BA. So our data is definitely garbage. And finally, there's one other one. And what I always just say is, some people, when they're picking it up, they pick up 2 of them, but then when they place them down, they place them this way. And then they pick up the next 2. They place them down, they place them this way. And whoops, sorry, I did a little bit off. And that gets us, in fact, yeah, let me do that again because, yeah, that was terrible. Failing to give priority to the second one. So instead of being A, B, C, D, they swap them. It's a lot easier when I have a lot of people in there because we actually hand these papers around and we talk about how it. But when they set them down, they end up with BA, and then CD. All right. So instead of us just arbitrarily throwing stuff, I want us to understand how is this swap byte doing? What is it actually doing? So we're going to go in here back to our routine, and I'm going to bring it. In fact, we'll just add another new rung because in the end, we'll tidy all this up. And we are going to go to the Move Logical tab, and we're going to bring down an SWBP swap byte instruction. We're not even going to worry about any of this tags that we already found. I'm going to make a tag called swap source. And I'm going to make a tag called swap destination. And then I do want these to be double integers. So we're going to create this one as a double integer. We're going to create this one as a double integer. And then we have an ordered mode, and this is what it's all about. Now, let's talk a little bit about the order mode with 16-bit numbers. Let's right click and go to instruction help, because the order mode with 16-bit numbers kind of makes it a little mysterious about the swap byte. But if we go down to this order mode, notice if it's a 16-bit or an integer, all the options do the exact same thing. They're going to take the first 8 bits and put them in the second 8 bits and the second 8 bits and put them at the first 8 bits. But we have all 3 of these options. So people, when they're running this as an integer and they're changing these, it kind of confuses them because they're like, well, it seems to do the same thing. Well, you're 100% right. It does the same thing. But since we have a double integer, that means that they actually do different things. And so for first one, I'm going to make the order mode a reverse, the very first one. And we're going to finalize that. Okay, now what we need to do is we need to put a value in here where we can actually see things change. Now, with a decimal number, this is very difficult because the difference between 32,767 and 32,768 is a significant change binarily. But if we go here and we go to edit swap source properties, at the bottom we can change our style. And this just changes the view that we're seeing here. And I'm going to change this to a hex view. Okay, really quick note for all my instructors out there is nowhere in this sentence that I see say that you need to do a hexadecimal lesson before we do all this. In fact, please just leave that hexadecimal till near the end of the year. That way people quit messaging me saying they're going to drop their class because they can't understand numbering systems. It's really not that important for programming until way later, like right now where we're doing some intense communications. But okay, we made this one a hex. And that kind of gets us where it's into a shorter bit. And then we're going to do the same thing on the swap destination here. We're going to change its style to a hex. And then in this one's source, I'm going to make this DDCCBBAA. And we have a reverse order mode. Well, that takes these first 2 letters and puts them there, takes these second 2 letters and puts them there, takes your third, puts them there, and your fourth and puts them there. Or it reverses them on a byte level. All right, now let's do a wrong edit there. And instead of a reverse, we're going to do the word. Now, a word is 16 bits, which in this case is 4 of these letters. And so now we're going to have AABB. Well, the second part of it now is AABB. And then we got DDCC. Well, that's going to kick over here to DDCC. So we've got to figure this piece right here out when we're working through this. But there's just one more. Let's go ahead and do the last one here. And so this is a high-low. And so this keeps us on our 16-bit numbers. We're going to be, instead of AABB, we're going to be BBAA. And instead of CCDD, we're going to be DDCC. So those 3 swaps right there will probably get you to anything you need. But okay, now let's talk about how we figure this out. And yes, Tony Leroy and a few of you others, why that last step was such a stumbling block. Is all right, we're going to go ahead and start a rung at it now. Actually, no, I'll leave this one just in case somebody comes up with a question. I'm going to leave that one. I'm going to add another new rung. And we're going to take, actually, arguably already have it right here. We have copy combine. No, let's do it all again. Yeah. So no, one thing, we do need this again. We're going to do this again. We're going to do a synchronous. Actually, we do already have it. Yeah, there's no need. We can modify this one now. So I'm going to modify that first one we did. Really, we had a copy combine, and then we were copying to a real. All right, I'm going to delete out that second one for now. It'll be right back in a second. So we've combined those, and now we got to figure out, okay, well, which one of these do we actually need here? And so what I'm going to do is we're going to bring down that swap byte instruction. And then actually I'm going to bring a branch down around it. And then we're going to right click that bottom left corner of the branch, and we're going to add a branch level. And now we're just going to copy that. We're going to paste it there. We're going to paste it there. We're going to do all three of them. That way we can see how we could compare and contrast and figure out what's going on here. So our source and all of them is going to be this copy combine. And then we're going to hit our order mode. So our order mode on the first one is reverse. Our order mode on the second one is word. Our order mode on the third one is high-low. And then for our destination on this one, this is going to be our combine reverse. And we'll create it as a double integer. The next one is going to be our combine word. We'll create it as a double integer. And then this one is going to be our combine high-low. And we'll create it as a double integer. Okay, since we have three different ones, now we need three different copies to put this in. So I'm going to go to File Miscellaneous, and we're going to bring down the CPS instruction. And I'm going to put this as our, these words are getting really long. We're going to make it our real reverse. Oops, I even typed that in the wrong spot. That's our destination. Our source on this will be combine reverse. Now, very slowly on this one, because you got to make sure you get this data type right. This one is going to be our real number. Because ultimately, we have a real number on ours. And our length will be 1. Okay, so now that's almost what I need. So I'm going to copy that there. I'm going to copy that there. This is going to be a combined word. This is going to be a combined high-low. This is going to be a real word. It's going to be a real high-low. And we'll right-click these. And we are going to make them real numbers. Okay, and then we're going to need these equals that we had here. In fact, we're going to delete these now, just so we can see what we have. So I'm going to put real reverse here, and drop that there, drop that there. It'll be real word. This will be real high-low. Oh no, I missed one of them. Oops, no, I just put the wrong data there. They're supposed to be real high-low, and I put combine high-low. Get that to the right one. Now, Tony and Ian, this is where you got to, and all of a sudden you're like, I can't quite figure it out. And here's where there was a slight hint, which, I kind of bounced back and forth on whether to put this hint in here. her last quiz, somebody's like, you don't give enough hints for us to figure this out. And I'm like, well, I've never really been working on a machine and not been able to figure it out, and walked up to management and like, hey, I can't figure this out. Could you give me a hint on how to do this? Well, I mean, now part of this is for us to think through problems. But yeah, I did actually drop a hint in here. And nobody quite nailed down which is kind of comical. Apparently, I don't know. I thought my hint was really good, but let me get to my hint. So when I put this quiz out, I put, due to some wisecracks in my last PLC quiz, I'm going to stay quiet on this one until somebody gives the correct answer. And wisecracks is spelled strangely. And that was your hint, is SEC stands for seconds. And while on the display of this flow meter, it is saying 102.9, it actually is running the data across in liters per second. And here's a perfect example. I actually did not find that documented anywhere out there. But if we take our number, well, we switch back to our standard calculator, 102.9, and we divide it by 60, we get 1.715. And there's your 1.715. So now I know it's reporting this in seconds. This is my correct number. And so I need to multiply that number by 60 to get minutes. So I'm going to go to my math tab. I'm going to bring an MUL instruction down. And we're going to take that real word and I'm going to multiply it by 60. And this will be our real word minute. And similarly, this will still be a real number. So real. And we'll finalize that. What? What did I do wrong there? Real word. Huh. All right, somebody in the chat's going to have to help me out now. What did I do wrong? Real word times 60. Why is that not working? Oh, I threw this equal statement in here. No, TA is not a data type. There we go. The control connection was good at spotting that. I and I do this all the time. I'll throw in equals that way, because if you're using a copy instruction, you can't see what's actually going on here. Well, if this isn't equal to 0, our multiply is never happening. That needed to be there. And that gets us to 102.9. And if we go back to the original one, it was 102.9. So through all that, that should give you enough as far as figuring out where the rest of your 80,000 pounds is, Jeff. And really, this is kind of key. Now, I do want to show one more thing, because the swap is kind of cool. It does a lot of things for you, but if nobody knows what a swap is, and yeah, I mean, if you're like everybody that comes to my class, this is what you do. You try the reverse, you try the word, you try the high-low. When it doesn't work, you're just like, I think your data's scrambled. What is it actually doing? So I kind of like the bit distribute method better. Now we're doing the exact same thing. Notice in the end, we had a word swap. Now a word is 16 bits. So that means we're taking bits 0 through 15 and putting them in 16 through 31. And we're taking 16 through 31 and putting them in 0 through 15. Well, the bit distribute does this on a binary level. So in this case, I'm taking that 198 and I'm taking source bit 0, 8 bits, and I'm putting them in a destination of 16, which is that upper word. And then I'm taking 99, source 0, 8 bits, and putting it in 24. And then 200 is the one that's the small number. So I'm taking its 0, 8-bit, and we're putting it to 0 of it. And we're taking 201 and we're putting it into bit 8. And for my connected components workbench, folks, you're going to be one more step away from this. Is another way, and I am going to go, yeah, because, yeah, Jeff, you asked for it. We'll go ahead and do a little, just one more step here. Here's another way just to kind of nail down what you're going to do in the video that, well, once the live stream's processed, I'll throw at you. Is what we could have done here is we go to our favorites, and I'm going to go look for a 1 down, and we're going to go to 198.0. Whoops, we got a dot somewhere in there. .0. Oh man, I did something brutally on that. Somehow we're going to get there. Oh, all right, let's just try all that again. I have no idea what I just did. .0. There we go. And I'm going to put an output energize to binary combine. And I'm going to create this as a double integer. So DINT. Now I know that 0 needs to go into bit 16. So .16. That gets that one. Now I need 80. I'm going to shortcut a little bit. I'm going to give you just a couple of them here just so you can see. Use your imagination a little bit. This will be 1. The next one will be 2, 3, 4, 5, 6. And then we will get 2. We'll go and put in. There's 6. And there is 7. So there would be more of them in here. And that would be 16. That would be 17. That would be 22. And that would be 23. And then we would continue to grab, in fact, should I? No, we're just going to copy one of them. And then we would go to 199 bit 0. And we would continue up. That would be 14. And we would, whoops. What did I do over here? I didn't finish. Oh, no, that's right. Oh, I just did terrible math. I think I said 22. Yeah, here's what I get for shortcutting. That should have been 22. And that would be 23. And then we continue up. This would be 24. And you would go on through that one. Whoops. Yeah, apparently my typing is not typing this morning. Okay, then we get to the 200 one. I'm going to copy and paste this. So we'll do all those through there. Then we get to 200. That would go into 0. And you would continue on through 7. So bit 7 here will be bit 7 here. And then finally, you would have 201. That would be bit 8. And you would continue that all the way down until you got to 2017. And that'll be bit 15. And yes, once this, which YouTube, it takes a little bit for it to process, but in a little bit after this processes, I will drop you a video that shows you all that. Let's see. I didn't actually do the chat today, but yeah, Fellstar, you're right. Yeah, this is all about, the single integer. Is it single integer or small integer? I never figure out what to call that. And yes, Jeff, I'm glad to help you out here. And Daniel, glad to have you here. Jeff Kuiper, as usual, usually you're always here. Good. In fact, I need to talk to you. I did have some safety questions. So yeah, let's catch up. Maybe we can catch up today or tomorrow. See, what's the application of this to pass data between PLCs? I would just use a message. Well, no, this TA, this is an issue of messages. That's what Jeff was doing here. Is when you do a message instruction, it can really easily this happens. Um, let's see, Stone Art, good day. Control connection, thank you for that. Oh, TA, you got it. I see you there. Oh, hey, control connection. I don't know why I've never thought of that. Yeah, he is absolutely right. You know what? I always throw in equals here just to make this work. But if you did a move instruction, I don't know. I could bounce back and forth on this. If somebody sees a move, they think it's doing something. But he's right. If I had oops, I just messed up there. Undo that. If this had been a move instruction earlier when I had that mistake, that way would have worked. Yeah, you're right. But anyway, I've been wanting to make this video because it is you know, it's always an issue, and it's a growing issue because our networks are growing. In fact, I really I was planning on doing a kind of a more snowballed version of this. Is I have 3 IO links on our what we call the island trainer, and depending on what you plug this flow meter into, it actually does the different swaps. And so I was going to use as an example of okay, because everybody, a lot of you are like, well, if we know the part numbers of them, then we can look in the documentation. Well, no, I knew this flow meter. I knew I was using this message, but I had this intermediate item that was handling the data in different ways. So being able to identify that data is pretty key. Anyway, y'all have an outstanding Saturday, and I have training class this week. I am doing some recording though, so I've several of you have asked for about some upgrades to your trainer, so I am doing a video on how you can add, you know, power flexes and some various things to it. Really cool new trainer, compact guard logics. If all goes well, it'll be out in a few weeks. And yeah, I've got a cool new IO link setup that I'm gonna try to get built out that I think y'all will like. So have a great week.